Okay, we don't recorded the introduction, but anyway, that's fine. Let me give you the host, Jordan. Yeah, you can share your screen now.
Yeah, so okay, hey everybody. So in this session, we will cover chapters 13 and 14, cross-canister calls and HTTP requests. So yeah, I'll give a quick overview of what we have covered so far. Basically, we've covered a lot about developing inside of your own canister or application. We learned about how to export, your read-only methods and your read-write methods, query and update methods. We talked about all the types generally that you can use, and we talked about storing things in an actual data structure that will keep your state around even across upgrades to your code. So now, today, we're going to talk about basically how to interoperate with other canisters or even other just general web services. And this concept is called, I guess, the concept of going cross-canister, right? We're going to leave our canister and try to call the query or update methods of other people's canisters. So that is the main purpose here. So I think it'd be great to just start building a simple application. I'll just kind of do it from the ground up. We have all our basic stuff. Remember, package.json just has Azle, and our dfx.json, this is where we list all of our canisters. So I'm going to make a simple application that has two canisters, canister 1 and canister 2. And we're going to basically get these two canisters to talk to each other. So here's a directory for canister 1 and a directory for canister 2. Okay, so let's start with canister 2. We'll make canister 2 the main canister that we'll be talking with. So basically, let's start getting some stuff from Azle. So imagine you have a very simple method called getMessage. And all it says is, hey, this is a message from canister 2, right? And this could be anything. This could be like a token. It could be some database, just some service that you don't have access, that you didn't create yourself, that is running on another canister. So that's all we have here. Pretty simple. Imagine your canister over here, canister 1. Imagine you want to talk to canister 2. So what are you going to do? Well, what you need to do is you need to create something called a service that represents the canister you want to talk to. How you do that is you make a class and you extend from service. Then what you need to do is essentially decorate methods or properties in this class that match the ones over here. So I have a getMessage method, so I'm going to say getMessage. It doesn't have any parameters, and it returns a string. Now, there's one more thing I need to do on the return type. I need to actually wrap it in this call result. Okay, so this service here represents an interface that I can use to talk to this canister over here. Now, to actually talk to the canister, I need to create an instance of the canister. I can do that like this. And just make an instance of it, and then I want to pass in the principal of that canister. We've talked about principals before, and principals are essentially identifiers on the internet computer. So I don't know the identifier yet. Actually, I've already pre-deployed these. So I'll just grab the canister ID from here. There are other ways to get the ID, but basically I'm just going to hard code this as my canister 2 canister ID. And now, boom, I have this canister 2 variable just stored globally where I can talk to canister 2 from canister 1. Now let's make my own update method here. I don't know, I'll call it like get canister 2 message. is actually going to be an asynchronous function. Whenever we talk to another canister, generally speaking, if we want a response, we need to use async await, and it's going to be an asynchronous thing. So I expect that to return a string. And I call it very simply. I just use canister2 as my variable. Dot, and I can see that there are some properties on here. Get message is what I want. Dot call. Boom. This will execute a cross canister call, and then I'll get a result right here. Notice this result is an actual result, meaning it's going to be an object with one of two properties present, OK or error. So I can check. If result.error does not equal undefined, I don't know if you remember, but the other day I kept trying to do error in results like this, and it wasn't quite working. Yeah, I didn't know that had, I guess, broken. So the better way to do it right now would just be to check if the property is undefined. So if result.error is not undefined, that means that we have an error. Don't try, by the way, to try catch this. That's not really going to help you. It's not going to throw, right? Right now, the API is designed to, and as far as it's possible, always return a result to you. If there was an error, then the error property here will be defined, and you can grab it out and do something with it. So in this case, if there was an error, I'll just trap, and I'll pass the error in as the message. Remember, trapping will stop execution and return a message. And that's the basic gist of trap. Okay. If there is no error, though, then my OK property is here, and it's a string. So this will be my string if everything worked. So this is the most basic way to talk to another canister on the computer. Here's my other canister. Here's the initiating canister. I make a little interface here called a service to talk to the other canister. I create an instance of it using the principal of the canister. And then to actually perform the call, I make an asynchronous function and just do a simple async await, check for my error, otherwise return OK. So we will deploy this. This will deploy both canisters because I put both of them in my dfx.json. All right. Okay, they're both ready basically. So let's start by just calling canister2 directly. So if I want to just call canister2, let's do it like this. So you can see if I go straight to canister2, it returns my message. Now, actually to prove, let's prove this. Oops. Prove to you that this is from canister1. I'll redeploy canister1. Okay, now we're going to call into canister1, and then we'll have canister1 call canister2. dfx, canister call. We'll talk to canister1 only, and we'll call the get canister2 message method. We should get from canister1 message from canister2. Sweet. So let me pause there. Any questions? This is like this is the most basic concept. If you can understand this, then everything else just builds off of this. Okay, let me know if you do have questions. We'll move on to making this a little bit more complicated. So let's actually build more of a real world example of doing cross canister calls. imagine you have a token, right? Like a cryptocurrency or something that you want to communicate with. On the internet computer, your token is going to be basically contained in a canister. So we'll make like a fake token, not following any standard, just using basic concepts. So we'll make a function called transfer that can transfer these tokens. When you want to transfer a token, generally you'll want a to address, an amount. We'll just use nat, simplest thing. We'll just return that amount. We need somewhere to store our balances. So just import a stable B-tree map. Our balances are simple. It's just a mapping of principals to balances like that. We'll use memory ID 0, and we'll just say that these are limited to 100 bytes each. And this must be essentially like that. Okay, so now we have a simple B-tree map where the keys are principals, which are identifiers, and the values are nats or big integers under the hood, which will be the actual balance. And then we'll do a quick transfer. This will be very unsafe. We won't check anything. But basically, to transfer, all we need to do is determine the from principal, go and get the current balance of the from principal, get the to principal, go get the current balance of the to principal. And then I just subtract the amount from the from principal and increase the amount of the to principal. I mean, this is like, it's like the simplest way to think about a token or a bank account or something, right? Just transfer. So let's get our from balance. So we'll go into balances and we'll get, the from in this case is going to be the caller. So I don't think we've talked about this concept yet. But every time a method is called, that method will be authenticated with basically a public-private key pair. So if you're making an HTTP request into the internet computer that calls one of these methods, for example, from the browser, then you will probably have made a public and private key pair in the browser, and you will have signed the message that you're sending with that key pair. The internet computer will automatically authenticate and make sure that the signature is correct, and it will place into IC.caller the actual principal, like the actual identifier from that signature. So you can basically rely on this to be correct. So we will use IC.caller as the from. So whoever calls this transfer function, we're assuming that is the person or the account that wants to transfer funds. So we'll go get the from balance. Now get returns an opt. We talked about opts in the past. So to actually get the value out, we're going to use the match function. So we'll match on this. Remember, this is an object with either a sum or a none. If it is sum, we'll just return that. If it's none, we'll just return 0. Okay, so we try to get the from balance. If there is a balance, we'll return it. If there's not a balance, we'll just say it's 0. And then we'll go get the to balance. We'll match on balances.get to, and then we'll do the same thing. Okay. And now we have our balances. Then basically we just need to write into the balance stable B-tree map. We need to change the from to be from balance minus amount. And then 2 will be the to balance plus the amount. And then we'll just return the amount. Okay, here's a simple transfer function. Hopefully you can see that this is very unsafe, because if from is 0, then the bounce, it won't become negative because nats can't be negative, but basically you can create infinite money like this. So, but it's just a simple example. So there we go. Canister 2 is now a little token, basically. The problem is that at first no tokens exist. So what we should do is we should give some tokens to somebody to basically become the minter. So we'll just do that like this. On the first load, let's just give a bunch of tokens to Canister 1. Let's go grab Canister 1's ID. And let's give Canister 1 like 1 million of these things. Big. Okay. So Canister 1 will have some tokens, so Canister 1 should be able to transfer some tokens. Okay, cool. Now over here, we need to update our Canister 2 service. We could even just call this like token. Okay. We have a transfer function. And I could just copy these params in here basically. And turn to net here. All right, this is now up to date. Now I probably want to change my update method to be something more like, I don't know, say that this is our minter. So we want to mint, and we'll put who we're minting to and the amount that we're minting, and we'll just return that out. So all we do now is do a cross-canister call. So the token, transfer to, put the amount in. It needs to be asynchronous. And then we need to actually perform the call. Okay, and we'll do the same thing as before. If result.error does not equal undefined, we will trap with the error. Otherwise, we'll just return the okay. This needs to be a promise. Okay, so now we have a simple token over here, which on load is going to give a bunch of tokens to this canister. When we perform a cross-canister call, IC.caller is going to be this canister. So we should have some tokens in here. And then we can transfer them to anybody that we want to transfer them to. So let's deploy both of these again. And then we'll see if we can transfer tokens. Also, it would be good to actually be able to see the balances. So make a get balance function. Just pass in the principal that you want, and it will be an opt net. So if it's there, it will return one. If it's not, then it won't. And let's deploy Canister 2 again to have that. Okay, so let's actually open up the little web browser. Let that deploy, refresh. Okay, so now we have a get balance and we have a transfer. So if we put Canister 1's principal in, we should see that has 1 million tokens. Yay, it does. Okay, but now let's transfer some tokens. So let's, this is like the, kind of like, I don't know, the empty principal. So it doesn't have a bouncer now. So let's first off, let's try to do an unauthorized transfer. Well, actually, unauthorized transfers will work because we didn't put anything in. So we'll just leave that there for now. Then let's actually open up another web browser. Actually, we could probably make this work right now. So basically, the from balance, yeah, all we need to do is say if amount is less than or equal to the from balance. If the amount is greater than the from balance, then we just need to trap, right? Insufficient funds. I think that should protect us. Should get this audited before using it for anything crazy. Okay, now if I try, yeah, so let's just try to transfer like 100 tokens. Should fail and say insufficient funds. Yep, insufficient funds. Because this token canister doesn't have its own balance. It doesn't have tokens. But canister 1 does have tokens. So let's go look at canister 1. Canister 1 should be able to mint up to 1 million tokens. So let's send 100 to this principal. Okay, it looks like it succeeded, so we can go over here and check the balance now. Yes, it was 100. That's so cool. Now let's try to send like 1 billion tokens. We only have 1 million, so it should, oh. Man, well, we have less than 1 million now, so. Cannot convert, oh, it's just that. Okay, it should say insufficient funds because we just don't have that many tokens. Yep, trapped explicitly, insufficient funds. Pretty cool. So that's a slightly more involved example. You can also do cross canister calls with, so if you notice, we're using updates, right? Update calls can call other update calls. If you want to do a query call, you actually can do that as well. So let's say that the minter, for some reason, wants to be a proxy. Let's say it wants to get its own balance. Yeah, just get the balance of itself. Then, oh, actually, I want to make this not return opt. I want to make this return. Either return the balance or just return 0. It doesn't really matter. Okay, so we'll change that. And then over here, we'll need to add this method. So we'll say that it's a service query, and it's called getBalance. And then we can just copy that to that, say call result. There we go. Then right here, all I have to do is get the balance. I have to pass in my principal, and I'll call it. And I'll just copy this. There we go. So it should tell me what my balance is. Doing a cross canister query call, otherwise known right now as a composite query. So let's deploy both of these. So yeah, hopefully you're getting the general concept, right? You have a canister that exports query note methods. If you want to talk to that canister, you make a service, and you just put the information in, right? If it's an update, you put service update. If it's a query, you put service query. You put the parameter types. You put the return type with this call result type as well. All right. Okay, now we have a good balance. Whoa, see, that was super fast. Whereas minting generally takes longer. See, that was an update cross canister call, so it's going to take a little bit longer, but this cross canister query is very, very super fast. There's a few more things you can do with cross canister calls. So sometimes a cross canister call might expect you to pay in cycles. Cycles are the units. You take ICP tokens and you convert them into cycles, and you use cycles to pay for computations on the internet computer. So if you do have a method that you're calling that takes cycles, what you would do is basically you'd load it up with some number of cycles before you do your cross canister call. And there's a number of methods like this. So cycles 128 just lets you pass in even more cycles. And then there's something called notify. Yeah, let's show you how notify works actually. Notify makes it so that you don't have to wait for the response. So in this case, we could make this entirely synchronous if we wanted to. If we don't care about the response for some reason, in this case, just say, I don't know, it wouldn't, you probably wouldn't want to do this for transfer, but let's say you just want to do something super quick. You don't really care. Maybe it's, I always think of like UDP versus TCP, where UDP just sends packets across the network super fast. Doesn't care if they get dropped, like for audio calls or something. Whereas TCP, you want to make sure the connection is established, that every single packet gets there appropriate. So transfer is just kind of a shoot and forget. If we do this, we should still be able to mint, but we won't know if it succeeded or not, and it will return very quickly. So we can deploy that and test it out. By the way, in Azle 18 coming out soon, we got this down to like 5 seconds or less. Which is nice. Okay. Okay, good balance. Oh, wait. I didn't realize, but the get balance is actually wrong. It shouldn't be 0, right? It should be oh, oops, hold on. We updated our interface, right? So, okay. Here our balance is 1,000,000 like it should be, but here our balance is 0. So let's find out why that is. Oh, I put in IC.caller. That's not what I want. I want IC.ID. IC.ID is my own ID. That's why that's broken. Okay. Oh yeah, so we were going to mint. So let's just wait. And we should be good. Nice. Okay, there we go. Now we have 1,000,000. Now let's mint to principal. Let's mint 1,000 of these things. They should return instantly. Well, not instantly. It should, however long an update call takes. And then, yep. So it worked, but notice it was completely synchronous. There was no async anything, and if there was an error, we didn't know about it. So, okay, that's a lot of stuff. Why don't I pause here again? Answer any questions. Okay. If there are no questions, then we'll move on. Yeah, that's cross-canister calls. If you want to go see many examples, just go check out all these examples in the Azle repo in the examples directory. All right, moving on to chapter 14. Now the chapters get a little sparse, so it's getting into, I guess, slightly more advanced material. But on the internet computer, you are able to receive HTTP requests, and you're also able to make HTTP requests. So let's talk about receiving HTTP requests first. So basically, this would be your canister acting as a web server, basically, right? And the way that you go about this is you make some types. One is the HTTP request type, which has the method, the URL, and the headers, and the body as a, I believe it's a UTF-8 encoded blob or event data array. Then you have your response. You put your status code in, again, your headers, your body as a UTF-8 encoded event data array. And then if you, the internet computer has some streaming capabilities. If you have an HTTP request that is bigger than the message size limit of the internet computer, which is 2 megabytes, and you can use this to do that. And the upgrade option, which I'm not as familiar with, but I believe that lets you basically convert from a super fast query HTTP response to something where you could actually change the state if you want to. Headers are just a tuple. A tuple is just an array with a heterogeneous array, right? The types are not the same, and you can have as many, an arbitrary number of elements essentially. And this is for the streaming stuff. This is func like we talked about earlier. And here's the most basic HTTP request handler, basically. And you just make a method called HTTP request, pass in, define your params, and do your response. So this will return basically an empty HTTP response, right? There's nothing really going to go on in here. And this is like the most basic functionality. So if you are familiar with Node.js, Node.js has similar functionality. It will have a lot more functionality because its networking capabilities are much broader. But this is like, the low level HTTP stuff. On top of this, we could maybe build abstractions like a fetch API or maybe get Express to work or something. But for now, that's what we have. So that's receiving HTTP requests. And yeah, I mean, to build things like, REST endpoints and RPC servers and everything, you just would basically look at the headers and you look at the method, the URL, the headers, and everything, and the body, and build all those abstractions on top and do that. So no one has really done that work yet in Azle. So if you're interested, that'd be great. Okay, that's receiving HTTP requests. Now we can discuss making HTTP requests from a canister to another, to the outside world, basically. This is a very cool capability of the internet computer, which is quite different from what many other decentralized computers or blockchains are capable of. You can basically build oracles directly into your canister so that you don't necessarily need to rely on a third-party service, which is very cool. So here we are going to import some types from Azle like we've always done. Then we're actually going to use a special virtual canister called the management canister. We'll get into the management canister more later in chapter 15. The management canister is going to allow you to make HTTP requests. And so you're going to need these types essentially. Here you go. Here is a prime example of making an HTTP request, an outgoing call to an Ethereum JSON RPC provider, basically like a Web 2 service that's providing access to Ethereum nodes. And notice it's a very familiar API. This is just a cross-canister call, but to the management canister in particular, and notice that we just import the management canister from here. And we just perform our HTTP request. We pass in our URL. In this case, we are just storing it in our stable storage Delvici map. You have to specify the maximum size you expect your response to be in bytes, otherwise it will charge you a lot of cycles. Pass in which HTTP method you want. Get and post are currently supported, though keep in mind that for post, because all the nodes in the subnet are going to perform the post request, the server must be set up for idempotency, otherwise it probably will not turn out like you want. In this case, we don't have any headers, but you can pass them in. And then we encode the body as UTF-8. And this is the Ethereum JSON RPC API. So we just make a JSON object, populate the fields that we want, turn that into a string, turn that into a UTF-8, I don't know, number array or something, and turn that into a UNT8 array. That's our body. And then we hook up what's called a transform function, basically. Because every single node on the internet computer is going to be executing the HTTP request, and because we need, this is a Byzantine fault-tolerant computer, we need determinism and we need consensus amongst the nodes. So in order for them to reach consensus, they need to be able to deterministically perform the HTTP request. So HTTP requests or responses can be quite messy. So you're able to hook up a transform function, and it's defined down here. And in this transform function, you get some parameters that let you basically transform the response. So you can remove things like dates or I don't know, anything in the headers that you don't need, and return everything else. So in this case, we just don't care about the headers. And so we spread everything else but the headers in to this object and just basically delete the headers. Then we're done. It does cost cycles, so we add cycles here. I think I got this number from doing it like without cycles, and then it telling me like, hey, you need to put in at least this many, so I just round it up to a nice number, and then I perform the call. I'll get a result, and so I match on the result. If it's okay, I'll get a HTTP response, and I'll just decode the response body. And that will get me a JSON string. JSON is just a type alias string right here. If it's an error, I'll just trap with the error. And then this is just another example of doing the same thing. So this is a same URL, and it's just a different JSON RPC API. So yeah, that is that's how you do outgoing HTTP requests. And I can show you just another example real quick. This is hitting a more traditional endpoint. This is the XKCD comic API endpoint. So I just pass in the URL to the comic JSON, and again specified the maximum size of my response. This time it's actually a get method. No headers, no body. I did put in a transform function, which is similar to the one you just saw. I just got rid of the headers, and I tacked on my 50 million cycles and perform the call. Match on the result. If it's okay, I get my actual response, which I just return. Otherwise, I will trap. And you can do like raw candid strings if you want. That's just what that's showing you. But you don't need to do this. It's just a capability you want if you want to be like super dynamic. Okay, well, that's basically it for today. We went over receiving HTTP requests, having your canister act as a server, and performing HTTP requests, having your canister essentially act as a client. Any questions before we wrap up?
Sarah, Bilal, any questions?
That's fine. I need to go through to the documentation, but understand the basics.
Well, sorry, I wasn't able to understand. What'd you ask?
I have no questions. I said
Oh.
I understand the basics, and I need to go through to the documentations.
Okay. Yep.
I'm like beginning on that.
Cool.
Thank you.
You're welcome.
Yeah, today I received several messages from the guys from ICP.Hub North America that they are involved in exams and other things. Yeah, that's why maybe today we don't have too much people join us, but anyway, it's going to be recorded, and yeah, we are seeing like a lot of good tractions and good feedback for the in general for these TypeScript courses. We will post today the last session, the third one, and during the weekend we will post as well the session, the fourth one, and maybe yeah for the next week we have the last two sessions. And I think maybe for the last one, we will have more people and questions. Yeah, but I think we can wrap it up. If it's not questions, Sarah, not sure if you are there. If you have any questions, I know you also finished the. You have any questions?
Hi, no, I have no questions. Thank you for your time.
Perfect.
You're welcome.
Nice, Jordan. Yeah, thank you so much. See you next week.
Okay. Good luck, everyone.
Thank
Bye-bye.
you, guys.
Thank you, everyone.
See
Have
you.
a good one.